Okay, moving on to our next type of shortcut. Same process, take what's given. It says XZ bisects angle WXY. So if an angle is bisected, this word bisect means cuts in half. Okay, bisect means cuts in half. So I'm going to put that as my first statement. How do I show that on my picture? WXY gets cut in half, so these two angles are going to be the same size. And that's what I have to write next, that this angle and this angle are the same size. So the angle that goes from WX to Z is congruent to the angle that goes from Y to X to Z. And that's because we know what an angle bisector is. So it's just a definition of angle bisector. Okay, I'm going to mark these with an A. Next, our given piece of information says WX is congruent to XY. So we mark our diagram that those are the same, and we add that to our proof. WX is congruent to XY. It's given. Okay, we know we have to end with this statement, so we know that goes at the very last line. So now I have to figure out what piece of information I'm missing. Okay, so I look at my diagram, I figure out, is there anything else I can add? This side that's in the middle is in both triangles. So we're going to say that XZ is congruent to XZ for reflexive property. I'm going to mark my sides with S's, and then I have to look at one triangle at a time. When I look at the triangle on the left, I can see I have an S, an A, and an S. The A is in the middle. When the A is in the middle, we call that included. That means between. And when we look at our other triangle, we can see the same thing, SAS. So this is our side angle side triangle congruence theorem. Okay, moving on to our next example. M is the midpoint of LP. So first I'm going to look at LP, and if M is in the middle, this and this have to be the same. So I'm going to put this statement on here, and I'm going to abbreviate a little bit. So the first thing I added to my picture is that LM is the same as MP, and this is just definition of midpoint. Finishing this statement, it says it's also the midpoint of NO. This is NO, so I'm cutting NO in half also. So the second thing I'm going to add is NM is congruent to MO. Same reason, it's just the midpoint again. Okay, so on my picture, I've got this side matching to this side and this side matching to this side. Now, I know what comes last. I know the triangles come last. So if this were drag and drop or a word bank, I know I'm putting that at the end. Okay, look at my picture. I do not have any sides that are in both triangles, so I can't use reflexive. I do see vertical angles. This angle right here and this angle right here are vertical. Remember, vertical are on opposite sides of an X. So I'm going to mark those angles congruent, and I'm going to put little A's there. How do I name that angle? M is in the middle, so LMN is congruent to, and this angle, M is in the middle, PMO. And that's just our vertical angles. And it's a theorem, but As long as you see the word vertical angles, you'll be able to tell which choice to pick. Okay. Now, when we cover up one triangle at a time, we see that we have an S, an A, and an S. The angle is between the sides, so it's included. And same thing on the other side. The angle is between the sides. So our final blank is going to be SAS, triangle congruent.